Hi fellas, this is Chemaddcts again to the solution. Welcome back to my another video tutorial. Well, today we're gonna study mechanics. Okay, so today's topic is projectiles. So at first, I'm really sorry. I'm really sorry for not uploading video tutorial in recent week since I was out of my house. I'm on a vacation. Okay, so let's get back to the topic. So today we're gonna do projectiles. There is another thing I want to tell you fellas. So I'm working on chemistry question solutions. It will be out sooner. So I know that you are waiting for that. So don't worry. I'm working on that. Okay. So let's get started. So today's topic is projectiles. So what we will do in this video tutorial, we will solve a problem. What things we would learn from this video? We will learn about some of the basic concepts that are involved in the problems, that are involved with the problems. Summary of this video. Here we will learn how to analyze the question and extracting some of the useful information hidden in the question. Use the information that are given in the question to form simultaneous equations by using basic concepts of mechanics. Okay. Relate each simultaneous equation with one another to find the values. Okay. So this is the study questions that we will do today. A particle is projected from a point on level ground with speed u per second and angle of elevation is alpha. The maximum height reached by the particle is 42 meter above the ground and the particle hits the ground 196 meter from its point of projection. Find the value of alpha and the value of u. So let's get back to the solution. Now let's solve this problem. Okay. So first thing first, we need to find the information that are hidden hidden in the question. Okay. So this is one piece of information. This is initial speed of the projectile. Okay. Angle of elevation is given by alpha. The maximum height reached by the particle is 42 meter above the ground and the particle hits the ground 196 meter. Well, there are two separate distances are given. Displacements are given. Okay, two separate displacements. So this maximum height, which is above the ground, is the vertical displacement. Okay. Okay, this is the vertical displacement, and particles hit the ground from its point of projection. This is horizontal displacement. Okay, horizontal displacement. So this one is vertical displacement and this one is horizontal displacement. Okay, and they have asked us to find the value of alpha and the value of u. Okay, so let us interpret this information that we have obtained from the question to the diagram. Okay, to this diagram. So this is u, which is u per second as usual. So this would be the maximum height, which is 42 meter. Here the corresponding final velocity would be 0. This is here the displacement, the horizontal displacement is 196 meter horizontal displacement, which we will denote it by x. Okay, horizontal displacement along x-axis, which is 196 meter. At this point, this is called time of flight. Okay, let me make this little thinner. Let me make this 0.5, so it will, the handwriting will be clear. Okay, so this is 196 meter. This is called the time of flight. Okay, so this is the time of flight. Here the the vertical displacement is 0. Here the vertical displacement sy is 0. Okay, so this is the vertical displacement, which is 0. Here it is the horizontal displacement. So did I miss anything? Yep, that is the acceleration a. Here a is the gravitational energy, which is 9.8 g, which is acting downward. Okay, so first thing first, let us resolve horizontally. Okay, so if you look at the initial velocity, there are two components. One is in the vertical component, and another one is in the horizontal component. And since we are resolving horizontally, we will take the horizontal component of velocity, which is ux, is equals to u cos alpha. Okay, here we will use another equation, which is d is equals to vt. uh, since there is no external force on the horizontal direction, so the velocity would be constant. Okay, is constant, so the velocity would be constant since there is no external force along the horizontal axis. Since there is no horizontal component of force, so the velocity would be constant. So now let us substitute the values. Here d is 196, here v is u cos alpha, here it is, and t is the time of flight. Now let us make t the subject, and we will get 196 u cos alpha. So let us name this as equation 1. Okay, so here it is. So I hope that you have understood this step. uh, Here we have obtained one equation. So this is one equation involving the time of flight and the horizontal component of velocity. So now I hope that you have understood this step. If you don't understand, please let me know in the comment section. Okay, I'm happy to help you out. Okay, so now let us resolve vertically. I need more space. So now let us resolve vertically, taking up as positive. Okay, so now let us follow the Subat constant, Subat format. Okay, I'm telling you that what is meant by Subat. S is meant by displacement, u is meant by uh, initial velocity, v is meant by final velocity, a is meant by acceleration, and t is the time. Okay, in this case we will take the horizontal displacement, which is maximum displacement 42 meter. Now we will take the vertical component of velocity, which is uh, u sine alpha. Here the velocity is 0. How? Since at the maximum displacement, the velocity is 0, the final velocity is 0, so we have taken velocity as 0. Here the acceleration would be minus 9.8, t is half t. Okay, since we have taken up as positive direction, so acceleration would be obviously negative since it is acting downward. So now let us choose the suitable equation for solving for solving. Okay, so if we consider these things, uh, we we will see that this value would rather make the situation complicated. How? Because we don't know about t, and if we involve initial velocity and initial velocity and this uh, displacement, then these two would be unknown, and this would make the thing worse. Okay, you may try that out by using other equation, but I have tried other method also, but I have found this thing suitable. Okay, this equation v square is equals to u square plus twice as. So this is the most simplest equation for this condition. Okay, so how? That's because the final velocity is 0, and here we also know the gravitational acceleration and the displacement, the vertical displacement, and this will make a nice smooth equation. Okay, so that's why I have chosen this motion equation. You may try by using other equations. Okay, u sine, here the u is, now let us substitute the values. U, here u is u sine alpha whole square plus 2. Here a is minus 9.8, s is 42. Okay, this is 42, not 41. Okay, so now let us simplify. By simplifying we will get u square sine square alpha minus 823.2 is equals to 0. Let us make this thing as a subject. Let us write this thing as a subject, and we will get 823 point u square sine square alpha is equals to this, and let us name this as equation 2. Okay, so we have obtained the second equation. By using these values. So this is true for all type of projectile related equation. First thing first, we need we need to first we need to resolve separately. Then second, we need to find the values by using the Suvat format. Okay, then this will make the math easier, simpler. Okay, so by the same procedure, let us find the Suvat. If you have noticed, we are gathering equations which we will use it later on. Okay, which we gonna use later on. So here now we will consider the vertical component of displacement as 0. Here the vertical component of displacement is 0 and the horizontal component is 196. Now we are going to concern about this value. The vertical component of displacement here is 0. U here is this u value is u sine alpha. V we don't know. A is minus 9.8 as usual. Here the t is the time of flight. So the suitable equation that I can see here is s equals to ut plus half at square. Okay, so s here is 0, u is u sine alpha, t is t plus half minus 9.8 t square. So let us simplify this thing. So if we simplify, we will get something like this: u sine alpha t minus 4.9 t square is equals to 0. Okay, so now let us take t as a common, then we will get something like this: t is equals to 0. Here u sine alpha minus 4.9 t is equals to 0, and here is another one, t is equals to 0. So let us now make t as the subject, and we will get something like this: u sine alpha divided by 4.9. Okay, so let us mark this as equation number 3. So fellas, now you can see that there are lots of equations. There are 3 equations that we have gained. There is one more equation left, then would be, we would be saved. Okay, it's not complicated, just work by the equation given. Just analyze the equation and work it out step by step. Just work step by step. Okay, so now what we're gonna do is, as you can see that in equation number 3 and in equation number 1, there is one thing in common here. The common thing is t is the common. Here t is the common, here t is also the common, so we can equate these both equations. It's just the simple arithmetic procedure. Okay, so equating 1 and 3. So why we are able to equate equation number 1 and 3? That's because here the time of flight is common thing here. Okay, so this equation matches with this equation, so we have equated it. Okay, equate this both equation 1 and equation 3. So let us write the equation of t. Here t is equals to 196 by u cos alpha, 196 by u cos alpha is equals to u sine alpha 4.9. So if you have rearranged, you will get something like this: u cos alpha, you just need to cross multiply u sine alpha 196 times 4.9. So here you will get u square sine alpha cos alpha and 960.4, and here you get the fourth equation. So let us summarize summarize things up. Here we can equate 1 and 3. That's because of t is common. Here t is common, that's why we are able to equate equation number 1 and 3. Since t is common here t is common. Okay, here t is common, that is why we are able to equate equation number 1 and 3. Okay, uh, so that's the thing. Now we have obtained the equation number 4. So what we will do now, so we will let us now look at equation number 2 and equation number 4. Okay, if you want to relate equation number 2 and equation number 4, just like we have related equation 1 and 3, now we are going to relate equation number 2 and 4. So if we have looked closer, we will see that they have a nice relationship. That is, in equation number 4, all these things are in product form. So u is in multiplication with sine alpha, and sine alpha is in multiplication with cos alpha in equation 4. Okay, and in equation 2 you will see that uh, u square is in u square is in multiplication with sine square alpha. So now, since they since there is only relation the only relation here is since the only relation here is since the only relation here is since the only relation here is product, so we can divide equation 2 and 4. Okay, so dividing 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 2 and 4, that's because the reason is we can simplify sorry can't even spell simplify since equation 4 and equation 2 are in multiplication. Okay, so now let us see. So now let us see. Now we are going to divide equation 2 and equation 4. So in equation 2 it is u square sine square alpha is equals to 823.2 divided by, so this is the equation 2, and we are dividing this with equation 4. So the equation 4 is here. If we have seen, The equation 2 is u sine square is equals to 823.2. Here it is. And the equation 4 is this. This is the equation 4. So the equation 4 is u square sine alpha cos alpha is equals to 960.4. This is equation 4. This is equation 4. We are dividing equation 2 and equation 4. As simple as that. So let us simplify this. This and this get cancelled out. Here 1 cancel out. The only thing that we have left here is sine alpha by cos alpha is equals to 823.2 960.4. So here we will use another relationship, that is tan alpha is equals to sine alpha by cos alpha. So here we will substitute the value with tan alpha 823.960.4. So now we are going to inverse tan inverse this value. So we will going to change the side of tan. So we will get tan inverse 823.2 divided by 960.4. So if you have calculated, you will get alpha as 40.6. 40.6 degree. So here we have got the here we have got one answer, that is the value of alpha. They have asked in the question about alpha, the value of alpha. We have able to find the one answer over here. Now we are going to find the value of u. It's really easy. Okay, so now we will substitute this value in equation 4. Substitute sub alpha is equals to 40.6 into equation 4. Okay, so what is the equation 4? Equation 4 is, sorry, not in equation 4, because cos alpha is present there, and it will make the math complicated. So we will substitute the value of alpha in equation 2, since there is only sine present, sine function is present there. Okay, I hope that you have understood. So u square sine square alpha, at first let us write the value, write the equation at first to make things easier. Okay, now let us separately find the sine value, sine alpha value. Here the value of sine 40.6 is, the value of sine 40.6 is 0.6508. So let us keep it as u square and substitute this value, since this thing means this one, sine alpha whole square to 3.2. Now let us substitute the value directly, 0.6508 whole square is equals to 8 to 3.2. Now just making you the subject, you square the subject. 8 to 3.2 divided by 0.0 sorry 0.6508. U is equals to root over 8 to 3.2, 0.6508. Therefore the value, if you evaluate this value, then you will get something like this, 44.1. so if we round off this one, you will get 44 meter per second. Okay, so the value of u is 44 meter per second. So this is how we are going to find the value of alpha and value of angle alpha and the initial velocity. Okay, so this is how we gonna solve this problem and find the values ultimately. And here what we have done here is we have just simply find the values by creating equation. By creating equation we have found the values. By at first we have created the equation, and second of all we have used the substitution method to find the values ultimately. Here we have done two things. Let me repeat. Here we have done two things. First thing, we have form an equation, and the second thing is we have just used the substitution method to find alpha and u. So I hope that you have understood the question as well as the answer. Okay, so fellas, how was this video tutorial? So I hope that this video tutorial has helped you with this type of problem. I hope that you won't face this type of problem in future. So if you have any type of question regarding this problem, so let me know in the comment section, and I'm always there, happy to help you. Okay.